Hello, everyone. Thanks for joining, and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our session today will cover OCI networking foundations, the solutions and services that are available today, what's planned next, some advantages customers have, and how easy it is to get started.
Hello everyone, my name is Aditya. I'm part of Network Cloud Architecture team here at Oracle. And also joined with us today are my colleagues Ati and Ionet. Our team's goal is to help customers understand, implement, and support the wide range of networking features available in OCI. Today, we are going to cover OCI networking foundations to help you get started with building the initial network constructs to support your future workloads in OCI. For today's agenda, we'll start off with a quick overview on OCI regions and VCNs, followed by gateways and VCN security constructs. Let's understand more about Oracle Cloud Network by starting with regions, availability domains, and fault domains. OCI is available globally from more than 48 commercial cloud regions, and we are rapidly building more new regions. Our goal is to offer proximity and meet requirements to keep the data in region or in country as needed, along with providing a true disaster recovery with multiple distributed cloud regions in every country. Oracle also has unique hybrid cloud options, including the dedicated region cloud at customer, which offers all our cloud services on the customer's on-premises. We also have a partnership with Microsoft and Google for directly interconnecting Azure and Google Cloud to OCI via Fast Connect without a third-party vendor in certain regions. This connectivity is supported in many of our OCI regions. In addition, we now also have multi-cloud products such as Oracle Database at Azure, Oracle Database at Google Cloud Platform, and Oracle Database at AWS in some of the regions. Within a region, we incorporate building blocks for high availability, starting with availability domains, also known as ADs. An AD is a completely independent data center that might be one physical building or campus with buildings that are in close proximity to each other. Some regions, like Ashburn, Phoenix, have multiple ADs within a metro area, while others consist of only one AD. Regions with multiple ADs have low latency, high-speed encrypted connections between each other. They are designed to have around 500 microseconds of latency between each other. Within each availability domain, data center racks are grouped into what's called fault domains. This provides additional levels of high availability by grouping hardware, infrastructure, and power into segmented units. By placing OCI resources, such as virtual machines, in separate availability domains or fault domains, you can build zero data loss architectures within OCI. Now we will discuss the virtual networking constructs, starting with the virtual cloud network. The virtual cloud network is a software-defined version of a traditional physical network, including subnets, route tables, and gateways on which your OCI resources run. The VCN resides within a single region but can cross multiple availability domains. A VCN covers a single contiguous IPv4 or IPv6 CIDR block of your choice. The allowable VCN size range is from /16 to /30. Oracle recommends using one of the RFC 1918 private IP ranges in the VCN address space that doesn't overlap with any of your existing private networks to avoid route conflicts in future. We can add more CIDR blocks to the VCN after its creation. But it's very critical to plan your VCN design thoroughly, considering all the use cases, workloads, and future growth. Here are the 5 main networking constructs for the VCN. Starting with the subnet, this acts as a unit of configuration to host your resources such as compute instances, load balancers, or databases. All subnets consist of a route table which defines the path for destinations that are outside the VCN. DHCP options allow you to specify things such as DNS servers and FQDN search domains. A security list provides ingress and egress firewall rules for the entire subnet. And network security groups, another type of access policy within VCN, also known as NSG, is assigned directly to an instance VNIC. We will discuss all these resources in detail in the upcoming slides. For subnets, you will need to carve out a network range from the VCN CIDR block. The subnet always reserves the first 2 IP addresses for the network and gateway address, along with the last IP in the block for the broadcast address. Each subnet can be eddy specific or can be a regional subnet, which means it spans all the eddies available for the region. We recommend regional subnets for high availability purposes. Note that each subnet cannot overlap with any other subnet IP range. Instances and other OCI resources draw their internal IP address and configuration, such as DHCP services, from the subnet configuration. Subnets can also be designated as either private or public. In private subnet, resources are assigned a private IP. In public subnet, along with the private IP, resources have an option to get a public IP assigned from Oracle's public IP pool. The route table is used to send traffic out of the VCN. A single route table is assigned to each subnet within the VCN. The same route table can be assigned to multiple subnets. There is a default route table created in each VCN that's assigned if you do not specify a custom route table. We recommend to use customized route table instead of the default one. A route table consists of a set of route rules. These rules specify the destination followed by the next hop route target, such as a network gateway or private IP address. Note that routing rules are not needed to allow network traffic for resources within the VCN to communicate with each other. But if you have scenarios where you need to send the intra-VCN traffic to a virtual network appliance, you can route to a private IP within the VCN. Every virtual machine or VM requires a primary VNIC which is created at launch. While additional VNICs can be configured on a VM afterwards. Number of VNICs is determined by the shape you choose for the virtual machine. Each VNIC added is recognized by the instance operating system. Let's go through some examples. In this diagram, VM1 represents basic configuration that has a single VNIC. VM2 has its 2 interfaces extended in 2 different subnets but in a single VCN. This is typically used for network virtual appliance scenarios. VM3 has its two interfaces extended in two different VCNs. This is beneficial when network isolation is required for security purposes. A public IP address is an IPv4 address that's reachable from the internet. These IPs can be assigned to OCI resources deployed in a public subnet, such as instances, load balancers, and network load balancers. For a public IP to be reachable over the internet, its VCN must have an internet gateway along with the route tables and security rules configured accordingly. Each VNIC can have up to 32 secondary IPs, and each can be associated with a public IP. There are two public IP types: ephemeral and reserved. Ephemeral IPs are temporarily assigned and exist for the lifetime of the instance. Once the instance is terminated, the public IP will be removed permanently from your tenancy as well. Reserved IPs will become part of your OCI IP pool. These IPs persist even after the termination of your instance. In this case, the reserved IP will be unassigned and reallocated to your IP pool. This IP can then be reassigned to another instance. There is no charge for using public IPs, no matter if they are ephemeral, reserved, or unallocated reserved IPs in your IP pool. Now let's learn more about the network gateways on OCI. A gateway is a network component that allows data to flow from one network to another. Gateways serve as network entry and exit points, as all data outside a network must pass through it. Here, we have a quick intro of each gateway. First, we will start with the Internet Gateway. Then I will explain NAT Gateway, Dynamic Routing Gateway, and Service Gateway. Then we will continue this with peering gateways in OCI. Internet Gateway will give bidirectional connectivity. So we could egress out of the cloud infrastructure towards the internet. Likewise, we can connect back onto the public IP of a given instance in a public subnet to manage the compute instances. For example, SSH connection requests or HTTP connections. There are some key points to consider. Resources that need to connect to the internet must be in a public subnet and have a public IP address. Each public subnet that needs to use the internet gateway must have a route table rule that specifies the internet gateway as the target. We need to specify security rules to control the types of traffic allowed in and out of resources in that subnet. A VCN can be attached to only one internet gateway at a time. The NAT gateways, on the other hand, only enable outbound connections to the private subnets, like perform patches or upgrades, or when resources just need general internet outbound connectivity. NAT gateway is added to give instances in private subnet access to the internet. With the NAT gateway, these instances can initiate connections to the internet and receive responses, but they cannot receive any incoming connections initiated from the internet. NAT gateways are highly available and support TCP, UDP, and ICMP ping traffic. Service Gateway allows resources within our virtual cloud network to access public OCI services in Oracle's services network, such as object storage, but without using internet or NAT gateway. So your traffic will stay on the Oracle backbone. One of the many popular use cases here is for databases backups to object storage. Please note that the service gateway supports only client to service traffic. That means on the outbound connections initiated from VCN to the Oracle Services Network is supported. Service gateway can be created with two types of access configurations. First is object storage access, and second, all the Oracle Services Network services access. How we manage the customer on-premises traffic differs, and we can handle that traffic with Dynamic Routing Gateway or DRG. A DRG connects remote on-premises or other cloud provider networks to VCN. A DRG provides a single point of entry for remote network paths coming into VCN. It provides a path for VCNs to communicate to on-premises across regions or outside the region. Each VCN can have a single DRG. Regarding the DRG use cases, we can say that a DRG is used while connecting from on-premises environment to the VCN using IPsec VPN, Fast Connect, or both. A DRG is also used while peering two VCNs in same or different regions. The latest version of DRG is DRG version 2. It acts as a virtual routing hub on OCI. DRG supports BGP routing and advertises all siders for subnets created in the VCN via BGP into the route table assigned to the DRG. With DRG, everything works as an attachment. Types of attachments include VCN attachments, remote peering connection attachments, IPsec tunnel attachments, and virtual circuit attachments. This allows us to have a scalable network design and efficient net remote connectivity. DRG can have up to 300 VCNs attached, and they don't need to be in the same tenancy. Hence, it acts as a virtual routing hub in some popular scenarios such as hub and spoke model deployment. We can assign a different route table and policy to each network attached to the DRG. With the help of these customizations, DRG makes it possible to have granular routing policies. Now let's try to put some of the things together that we learned. As mentioned earlier, there are two subnet types within a VCN: a public subnet and a private subnet. A public subnet allows resources within the subnet to have direct bidirectional internet communication, while private subnet are used to prevent direct external access to resources such as a backend database server. Here is a high-level diagram showing the gateway types used in a private subnet versus a public subnet. In the route table associated with the public subnet, a route rule pointing to the internet gateway enables bidirectional communication access to the internet. In the route table associated with the private subnet, a route rule pointing to the NAT gateway enables only outbound access to the internet. A route rule to the DRG allows the traffic over the private connection to your data center. Moving on, let's talk about the OCI gateway peering types. Local peering refers to the process of connecting virtual cloud networks within the same region so that their resources can communicate using private IP addresses. The VCNs can be in the same tenancy or different ones. The two VCNs in the peering relationship shouldn't have overlapping shaders. Subnet route tables must have routing rules pointing to the respective local peering gateways. A specific VCN can have a maximum of 10 local peerings at a time. Another way, and the recommended approach of peering two VCNs in the same region is using dynamic routing gateway. We recommend this approach rather than using LPGs is because you can attach up to 300 VCNs to the single DRG and hence is more scalable. Also, you can take advantage of DRG's capabilities to control the traffic more granularly. Remote peering refers to the process of connecting VCNs in two different regions. This scenario uses dynamic routing gateway. In this diagram, VCN1 in region 1 is attached to the DRG1 and VCN2 in region 2 is attached to the DRG2. Then both the DRGs are paired together to create a remote peering connection. This inter-region traffic traverses the Oracle backbone. And like local peering, the two VCNs in the peering relationship must not have overlapping shaders. Last but not the least, let's talk about the security constructs available in a VCN. A security list acts as a virtual firewall for an instance with ingress and egress rules that specify the types of traffic allowed in and out. Security lists are regional entities. Each subnet is associated with a security list. Security rules in the security list can be stateful or stateless. A default security list is always created with the VCN creation. As a best practice, we recommend to use customized security list for each subnet to better manage the security requirements. If customized security list is not used, default security list is always automatically attached with the subnet. All the resources such as compute, load balancers, or databases within a given subnet inherit all the security rules in a security list associated with that subnet. However, on the other hand, network security groups apply to VNICs of resources deployed within the OCI. When a group of nodes or group of VNICs need the same type of security, they can be grouped into network security groups. For example, a group of compute instances that all need inbound SSH access can be assigned to a single NSG having the security rules allowing inbound SSH access on destination port 22. Some of the services that support the use of NSG include compute instances, load balancers, database systems, autonomous database, and DNS resolvers endpoints. In summary, when you have multiple resources that require different security postures within a subnet, and you need to control the traffic at a more granular application level, in such cases, you can create those granular rules and add multiple resources using network security groups. The network security group and security list always work in conjunction, and essentially, they are the union of the two. This means that the traffic is allowed if either security list or network security group has a security rule permitting it. To wrap up the comparison of network security groups and security lists, we can say that they both have distinct functions. A security list applies security rules to all the VNICs in a subnet. In contrast, a network security group applies a set of security rules to a specific group of VNICs chosen by you. Unlike security list, the VCN does not have a default NSG. Also, the NSGs that you create are initially empty. They have no default security rules. Talking about the service limits, you can have a maximum of 5 security lists per subnet, and a particular VNIC can be a part of maximum of 5 NSGs. Now I will hand it over to Ati for a quick demo on OCI console. Thank you very much for your attention.
Hello, everyone. My name is Ati. I am a senior cloud network engineer here at Oracle. Thank you so much for joining us today. My peer Aditya just did a great job and walk you through the OCI networking fundamental. Now, I will take you through a demo to show you how it all works in practice. Let's dive in. Log into Oracle cloud.oracle.com. From the right side, you can choose your region. I chose UK South London regions. Navigate to hamburger menu, click on networking, virtual cloud networks, check your compartment and create VCN. Name your virtual cloud network. I name it demo VCN and then assign the IPv4 CIDR blocks, non-overlapping CIDR blocks. And keep in your mind, you can assign up to 5 IPv4 CIDR blocks now or even later after you created your VCN. Here is our VCN details page. And as you see, my VCN status is available. Look at the resources you have under the VCNs. You can create subnets and different gateways and route table from here. I started with creating public subnets. I name it public subnets, and subnet type would be regional. That's what we recommend. And let's assign the IPv4 CIDR blocks out of your VCN CIDR block to this, and access would be public subnets. Click on create subnets. And while this provisioning, let's create the second subnets. My subnet here is private type, so I name it private subnets. Double check the subnet type, regional. This is what we recommend. This way you would have access to these subnets, VMs across all the 3 availability domains in London regions. Subnet access would be private subnets, and click on create subnets. From this menu, as you see, we created our subnets. One state is available, the other one is still provisionings. We can wait a few seconds. You see both shows available now. Let's click on create route table. What we recommend is just creating the custom route table for each subnet type you have or you create inside your VCN. I will create one more for private. This one is the public subnets route table. Let's create the second one. I name it private sub RT or route table, and just click on create. So now I move on to internet gateway for creating the internet gateway for connectivity, access connectivity for the VM to the internet and connection back to that VM. And then I'm gonna create one NAT gateways for my private VM, internet access to outside. I choose the ephemeral public IP address for this NAT gateway, click on create. And then while we create our IGW, I will go to my route table, public subnet route table. I will add that target here. Target type would be internet gateway. Destination CIDR block is quad 0 or default route. Go back to VCN details page. Go back to the subnets. Here is my public subnets. I will edit my public subnets with the public subnets route table I just created. We'll go back to demo VCNs. Internet gateway created, assign it to the public route table here. I do not create any rules for private subnets RT. I'll do it later in this demo. But I will update my private subnets route table From the private subnet details page, click on Edit and update it to private subnets RT, save changes. Perfect. So now let's check our security list. By default, when you create your VCN, you would have these 3 rules available here, which the first one is all we need. And the second one is for ICMP or ping test from our compute instance. Now we have created our subnets and proper gateways. Let's move to hamburger menu, click on instances, and let's create 2 instances. I start with public compute instance or public access VM. Just name your instance. I name it public VM. You can place it in 3 available AD in our London region. I choose AD number 1 and choose your image and shape and ensure you are creating that in the right VCNs and subnet type, which is public. Don't forget to save your keys for SSH access to this VM and click on create. While this instance is provisioning, from the provisioning, we come back to the instance main page and just create my second instance, which is the private instance. I name it private VM. Pick the compartment, put in the right AD or availability domain. And as you see, right side, you have the estimated total based on your shape and boot volume cost. Choose your subnet, save the keys, and just click on create. Leave the rest default and just click on create. While my second instance is provisioning, it's going to take a few minutes. I already saved my keys for my public VMs. And now see the state of the private VM also changed to running. I use the SSH PODI to SSH to my VM using the public IP address of my public VM and saved key, which I already saved. And you see the public IP information is also available there. Just accept it, log in as OVC, which is the basically a username for this VM machine. And let's check the connectivity to the Google DNS primary IP address, which is 8.8.8.8. As you see, there is a connectivity to outside to the internet. And now I'm using this public VM as a jump host for getting to my private VM here. For accessing to this private VM, I need to save the private VM private key, which we already did that because we need to use it here. For accessing to private VM from OCI side, you have 2 choices. You can use the public VM or any public compute instance as a jump host, or you can either use the OCI Bastion services, which we will cover it in our future day 1 and beyond session soon. But here I use this public VM as a jump host and will SSH to my private VM from here. While I'm trying to connect to this machine, you see that from the instance page, you have the state of the instance, public IP, private IP, information is about the shape, all CPUs, and all the availability domain and fault domain informations. Even the date you created this instance is also available from here. Let's accept the fingerprints from here and let's double check. There you go. I am in a private VM or my private VM. Let's double check the connectivity to the Google DNS primary IP address. Perfect. As you see here, the ping didn't go through because there is no proper gateway attached to the private subnet route table. Let's go back to VCN details page to add the proper route rules there. Click on demo-VCN. Click on private subnets, and you see we already add the private subnet route table there. One more time, double check the security list, which is good. We have SSH port 22 and also ICMP there. Let's add the route rules there. Route rules, target type, this time would be our NAT gateway. Destination would be anywhere, from OCI to anywhere across the internet. Well, I go with default route quad 0. And let's double check my ping. As you see, there you go. The ping is started to running. And so NAT gateway is added to give our private VM in private subnet access to the internet. And that wraps up the demo. I hope this walkthrough helped illustrate how OCI networking fundamental works in practice. And thank you so much for your time, team. Thank you, everyone.
Thank you, Ati, for the amazing demo. Ganesh is asking, can we connect to VCNs without using LPGs? Yes, so there are two approaches basically, as we discussed. One is using LPG and second is DRG. The DRG is a more scalable approach because it allows you to connect up to 300 VCNs and you can control the traffic more granularly. See, Edward is asking, does one route table of a subnet can have route entries destinating to different gateways? Absolutely. You can have multiple route rules in a route table, but for the same destination, OCI won't allow you to put two route entries pointing to two different gateways or IP addresses. And it will follow the general rule of longest prefix match in the route table. The failover work in a network outage failure. All the constructs which are native to OCI are highly available, like all the gateways. So if you are asking about for example, there are virtual machines, then you should plan your design in such a way that you take advantage of your or multiple availability domains or fault domains. You deploy your applications which are highly available, putting them in separate ADs or FTs, or you can even utilize different regions. For example, you can have Ashburn as primary, Phoenix as secondary. So whenever we are talking about any secure connection from on-premises applications to any service in OCI, we basically have two solutions: site-to-site VPN and Fast Connect. Site-to-site VPN will provide encrypted connection over public internet. And Fast Connect is our service, which is a private dedicated connection. If the requirement is to have a dedicated and high bandwidth connection to your on premises. There is certification for OCI Cloud. Yes, we have many certifications available, and those are mentioned in the following slides as well. Starting with associate, we have professional as well, and if you want to learn more about networking, we also have professional networking certification. How do network security groups and security lists differ in OCI? When would you use each? So the best practice is to use both of them in union. So the best use case of that would be if you have your resources in a subnet and those all require same type of security control, then put those rules in the security list. For example, if you have 5 application servers in your subnet that all require SSH access to it, you put that rule in the security list, because that will then get applied to all of the resources within the subnet. Out of those 5 application servers, for example, if you want to provide only 2 of them with HTTP access, then you create a network security group. You add a security rule allowing HTTP connection, and you assign those 2 virtual machines or application servers to the NSG, so that only those 2 machines have HTTP access. How many security lists can be attached to one subnet? So you can attach up to 5 security lists per subnet. So we have some resources that will enable to get you started on OCI. We have many useful certification that was on the question in the Q&A as well. You can start with associate, that touches upon all the OCI constructs, including networking. Then move to professional, and if you really want to go in depth networking, network professional is an amazing course too. Talking about documentation, we have in detail content on reference architectures, service limits, or step-by-step instructions to implement OCI resources. To keep up with the latest features and announcements, you can visit Oracle's official blogging website. And to explore networking specific use cases and in detail implementation, you can visit ateamoracle.com, which is some of the content are written by our team. So thank you very much for your attention. Now I will hand it over to Stan to cover the remaining slides.
Thank you, Aditya and Adi, for an awesome session. We really appreciate your time and help. I hope this was a good learning experience for everyone. Here are just a few of our resources for our Oracle enablement. So we have hands-on experience with Oracle Clouds, and we also have a couple of courses from Oracle Cloud, which we offer through Oracle University and Cloud Training. If you enjoyed this session and would like us to conduct personalized training sessions for your organization, do email us at our personal training email and we will reach out to you. If you want us to conduct just hands-on labs, we have our newly designed Quick Shop Live Labs program for a more expedited hands-on learning experience for specific cloud topics. Under the Cloud Innovate program, we co-develop a solution based on your own use case. Please remember that personal training is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. Our next session will cover OCI connectivity options on April 21st. In this session, you'll be introduced to fundamentals of connectivity options on the Oracle Cloud infrastructures and how to start your account off correctly with best practices. Also, as part of our services, we do offer more through this Day 1 and Beyond series. And here are a few subjects that we do have, including core services, Oracle Analytics Cloud, and some of our hands-on series, as well as cloud security series, as this one is. With that, thanks for joining today's session and have a wonderful day.